Hello and welcome to Mr. Tompkins Ed Tech. In this video I'll identify the top 10 most likely topics you'll encounter on a calculated paper and run through some of the typical exam questions to help you prepare for that paper. There is a worksheet that goes with this video and I strongly recommend that you try the questions first yourself before watching. Thanks to Dawn Crichton from Spencer Academies Trust for pulling this worksheet together, by the way. You'll find a link to this paper below, so why not pause the video and go and download it now. Got it already? That's great. The idea is for you to try these questions yourself first, then watch the video to mark and up-level your work. This should help you identify what topics you are solid on and, more importantly, which ones you still need to work on. In the description below the video, you'll find links to further resources on each of these identified topics. So once you've finished here, you can tap on these links to target any areas of weakness that you still might have. Also in the description you'll find a list of further topics that may well also come up. Remember, I've only included the most likely here, but there will be others, and if you have time you should also work through those topics too. If you've not already subscribed and hit the bell, go and do it now. That way you'll be notified when I post more videos to help you succeed in your maths exams. Any questions, make sure you pop them in the comments below the video. Good luck with your preparations. And let's get into it. Okay, the first topic I'm going to be looking at today is factors, multiples and primes. So really you just need to make sure that you don't muddle up your factors and multiples. That's really important. Some students keep muddling them up. You should know your primes, at least up to 100. You should be able to recall and write them down and recognize them if you see them in the list. You need to know about prime factor decomposition and how to find HCFs and LCMs, either by listing outcomes or by combining products of prime factors. So we'll look at those, I'm sure, as we go through. Okay, so first off, write down all the factors of 12. Now it's not hard to find factors. The trick is to get all of them and not miss any out. So I mean, I tend to do these in a little T-table like this. I put the number at the top and I write them down in factor pairs. So I start with the number 1 and think what 1 times what is 12? It's 12. And then I go up the number line. So 2 goes with 6, 3 goes with 4, and so on, until eventually you kind of meet yourself coming back down the other way. So there's no numbers between 3 and 4, so I know I've got them all. Okay, so all of the factors of 12 would be 1, 2, 3, 4, 6, and 12. Question 2, part A, write down all the factors of 18. Similarly, if I write 18 like that, I'm going to start with 1 and 18. Try 2, yeah, true at 2 and 9. Try 3, yeah, 3 and 6. Try 4, no, 4 doesn't work. 5, no, 5 doesn't work. And then I've met myself coming down the other way, haven't I? Because the next number is 6, and yeah, I've already got 6 on there. Okay, so that's all of them there. So that's 1, 2, 3, 6, 9, and 18. And then part B says work out the lowest common multiple of 12 and 15. Now, when the numbers are small, like this, I tend to just do an exhaustive search, just list out a few multiples of 12 and multiples of 15 until I find one that's in common. So multiples of 12 first: 12, 24, 36, 48, 60, 72. And multiples of 15, 15, 30, 45, 60, 75. Now, hopefully, before you go too far, you'll find that you've got one that's the same on both lists, and then that will be your LCM then, isn't it? So the LCM of those two numbers is 60. Question 3 says, work out the multiple of 60 that is closest to 400. Well, going through the multiples of 60 then, 60, 120, 180, 240, 300, 360, 420. So it's going to be out of those two, isn't it? They're either side of 400. 400's in the middle here. Now 400 is closer to 420 because the gap there is 20, whereas the gap between 360 and 400 is 40. So I'm saying that one there is the closest. So 420. Question 4 says write down the 2 prime numbers between 25 and 35. Okay, so again, just knowing your prime numbers, certainly up to 100 would be very useful for the exam if you can remember them. So you've got 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. What comes after 29? 31. And I think that's it, isn't it? Because I've got them all now. So two prime numbers between 25 and 35. It's going to be 29 and 31 there. Okay, so 29 and 31. Work out the highest common factor of 12 and 18. Again, when the numbers are small like that, probably an exhaustive search is going to be the quickest way. So finding all the factors of 12, we already did this a second ago, didn't we? So 1 and 12, 2 and 6, 3 and 4, and finding all the factors of 18, 1 and 18, 2 and 9, 3 and 6, and that's it, wasn't it? So what is the number, the biggest number that's on both lists? Well, numbers on both lists are 1, 2 and 3 and 6. Look, 1, 2, 3 and 6. And the largest number on both lists, it's the same, which is the 6 then, isn't it? So the HCF of these two numbers is 6. Okay, so again, when your numbers are small, an exhaustive search where you find all the factors of both and compare them is probably the quickest way of doing it. Question 6, complete the boxes using a square number and a prime number. Okay, so something divided by something is 18. So it has to be an even number to start with, to end with. Well, I guess I could use 2 as my prime number, couldn't I? What would I have to halve to get 18? It would be 36, and 36 is a square number, isn't it? Because it's 6 squared. So 36 divided by 2. Question 7, complete the boxes using a factor of 12 and a factor of 40. So factors of 12, what are the factors of 12? 1 and 12, 2 and 6, 3 and 4. Factors of 40, 1 and 40, 2 and 20, 3, no, 4, yep, 4 and 10, 5, yep, 5 and 8, 6, no, 7, no, and then I've met myself come down the other way, so that's all of them. So I need to pick one number from each, so I'm going to get 30. Factor pairs of 30. I've got 1 and 30, 2 and 15, 3 and 10, 4, no, 5, yeah, 5 and 6. So can I pick one of those from each? Well, there's two ways of doing it, actually. I could pick the 3 and the 10. They multiply together to give me 30 because I've got a 3 there and a 10 there, so that would work. Or could I do the 6 and the 5? I think I could do the 6 and the 5 as well because I've got a 6 there and a 5 there. Okay? So, yeah. Either of those would work. I don't think I can do a 2 and a 15, and I can't do a 1 and a 30. But yeah, any of those two pairs would work. So I could do a factor of 12, 3, a factor of 40, 10. There we go. Question 8. Write down all the prime numbers between 40 and 50. So carrying on from our list that we had earlier, I think we got up to 29, no, 31. So what's after 31? Then you've got 37, 41, 43, and 47. Now, if you're struggling to remember, there is a quick way of checking if it is a prime number. You can use the prime factor decomposition button on your calculator. It's a calculator paper, this one, isn't it? So if I just want to double check 41 is actually a prime, if I press 41 equals and then shift fact, it's going to tell me 41 again because there's no prime factors of 41 other than 41. Similarly with 43, if I press 43 equals and then shift fact, you can see that's just going to give me 43 back, and 47, and then shift fact, you can see that just gives me 47 back. Now, if you put in a number that isn't a prime, so if I typed in 49, maybe I was thinking 49 was a prime, and I press shift and then fact, you can see it's going to convert it to 7 squared for me, and I know immediately then it can't be prime because 7 is a factor. Okay, so yeah, that's quite a handy button if you just want to know whether or not a number is prime or not, and you've got your calculator, then that's a handy trick to know. So numbers that are between 40 and 50 that are prime, then that's 41, 43, 47. Question 9, write 300 as a product of its prime factors. So like if you didn't have a calculator, you could do it with the little tree like this, where you find two numbers that multiply together to give you a number, and you keep going until you get to prime numbers. So you can have 30 and 10. 30 breaks down to 3 and 10. 3 is prime, 10 isn't. I can break that down to 2 and 5. 10 I can break down to 2 and 5. So you can do it that way, and then your prime factors are going to be all the leaves at the end that you get. So that's going to be 2 times 2 times 3 times 5 times 5. However, if you've got the calculator, much easier just to type it in. 300 equals, and then if you've got the old calculator, shift and then fact, or if you've got the newer one, you can just go down and press the format key and then select prime factors, and that's going to give it to you as a prime number, as a product of its prime factors, which is 2 squared times 3 times 5 squared. Now you can either write it out long, you can write it out as 2 times 2 times 3 times 5 times 5 in this case, or you can write it as in index form. Sometimes it specifically asks for index form, so you do need to write it that way if it asks. Okay, so 2 squared times 3 times 5 squared is my answer. Question 10, this table shows what 20 students do for lunch. 7 have sandwiches, 5 have school dinners, and 8 go home. Draw a bar chart to show this information. Okay, so I'm going to have a number of students up the side. Okay, and then I'm going to have either sandwiches, school dinners, or go home along the bottom. Okay, now I'm just planning this out. You need to have a gap between your bar, and all the bars need to be the same width. So I'm kind of thinking that I'm going to have like 2 squares for my bar, and then a gap, and then 2 squares for my bar, and then a gap, and then 2 squares for my bar, like that. That would fit nicely on there. Obviously I need to draw them at the right height. So putting my scale on the side from 0, 1, 2, 3, 4, 5, 6, 7. Need to go up to 8, don't we? Along that side for the number of students. And then along the bottom then I'm going to have sandwiches, of which there are 7. So I'm going to have to draw a bar which is of height 7 on my diagram. Then next I've got school dinners. And that needs to be of a height 5. And then finally I've got go home, haven't I? And that is of a height 8. Now you really don't need to waste time shading them. You're not going to get any extra marks for doing it. As long as the bars are the right thickness, you have the right gaps in between them, and they're the right heights, you're going to get the marks. Okay. So places where you can lose marks, not writing your scales. So making sure you've got your numbers written here, making sure you've got titles, making sure the widths of the bars are consistent all the way through, so they're all the same width, making sure that the gaps in between the bars are the same between all of them. Preferably use a ruler, guys. Come on, you know, how hard is that? Then yeah, you should get the marks. Question 11, the bar chart shows the number of medals won by a country at events in 2008 and 2012. So we've got a composite bar chart here. So I've got 2 sets of bars. The darker bar is the gold, the lighter bar is the silver, and the other one is the bronze, the middly bar. Okay, and then we need to answer some questions about this composite bar chart. So complete the statement about the medals won by the country in 2008. The number of silver medals equals something times the number of gold medals. Well, in 2008, that's the first set of bars, isn't it? So how many of each have we got there? So for gold, there are 2 gold medals, and then the silver is that kind of taller one. And then the silver one is the middle one, that's 6. So 2 times what is 6? It's 2 times 3, isn't it? So it's going to be times 3 there. Show that the country won. Part B says, show that the country won more medals in 2008 than in 2012. So we need to know what all the bars are now. So my third bar there is 9. So that adds up to 2 plus 6 plus 9. So in 2008, there were, how many medals? 2 plus 6 plus 9, that's 17 medals were won. And then in 2012, how many was it? It was, well, that's 5, that's 8, and that is 3. So 5 plus 8 plus 3, that comes to 16 medals. Okay, so I've shown that the contrary, yeah, 17 is bigger than 16 then, isn't it? So that's kind of shown it clearly. I think that's good enough. Part C says, at the 2016 event, the country won an equal number of each type of medal. Here is a statement about the medals won by the country in 2016. The total number of medals cannot be 25. Give a reason why this statement is correct. Well, okay, well, if there was an equal number of medals, then the number of medals in total needs to be a multiple of 3, doesn't it? And 25 is not in the 3 times table. So 25 divided by 3 is, well, it's 3 goes into 25 8 1/3 time, isn't it? So because it doesn't go in as a whole number, then obviously then there can't be an equal number of medals. So I'm just going to write then that the number of medals is a whole number, and 3 is not a factor of 25. Okay, I think probably I've written far too much there to get the mark. And probably just writing 25 by 3 is not a whole number. It would have been sufficient. Okay, but anyway, we're done. Let's move on. Question 12. Students choose juice with their school meal in the ratio of orange to apple to lime in the ratio of 5 to 2 to 3. Complete the bar chart. Well, if you have a look at our bar chart, the orange juice is 20 and the apple juice is 8. So if you have a look at the ratio of 5 to 2 to 3 for orange, apple and lime, then in actual fact we've got 20 to 8 to something, and so the actual numbers are like the ratio we've been given multiplied up by a factor of 4 then, isn't it? So if I multiply 3 up by a factor of 4 as well, you should find I've got 12 then for lime, and that's the height of the lime bar that I need to add on. Okay, so I need to add an extra bar to the bar chart of height 12. Needs to fit the general bar chart as well, so this, you know, the same width, the same gap in between as the other 2 bars is required. So I'm just going to make sure that is the case. Yeah, so like that kind of works. So that's going to be my line bar, height 12, same width as the other, same gap in between the bars as the other. Question 13, the composite bar chart shows information about the percentage of drinks sold by a cafe in 2007 and 2019. So this is a percentage, okay? So it's broken down as 100%. So the 2 bars in 2007 and 2019, they're drawn at the same height because they're represented as a percentage of the total sales, but they're not necessarily equal to each other in terms of the number of sales. They might have had more or less sales in 2019 compared to 2007. Okay, so just something to bear in mind with this chart. In 2007, the cafe sold a total of 24,000 drinks. How many more teas than coffees were sold? Okay, so we know that the total number of drinks was 24,000. Okay, and then how many more teas than coffees were sold? Well, teas is the white part of the bar and coffee is the grey part of the bar. Now, if you have a look at the coffee part first, that goes up to one little square above 40. Now, there are actually 5 divisions between there and there, so each one of those must be like 2. So like 42, 44, 46, 48, 50. So that means that the grey bar is 42 then, isn't it? Okay, so 42% then of the sales were coffee. What about tea? Tea goes up from the 42 all the way up to 90. So 90 take away 42, that's 48, isn't it? So 48% of the sales are tea. So what as a percentage, how much more tea was sold compared to coffee? Well, 48% minus 42% is 6%. Okay, so really all I need to do is find what 6% of 24,000 is. Okay, so final, original, multiplier. What we've got here. The final is what we're trying to find. The original is the total number of drinks sold by the coffee shop, which was 24,000, and the multiplier is going to be this 6% then, but written as a decimal number. So 6% as a decimal is 0.06. Okay, so what I want then is final equals original. Covering up the thing I want to find. Look, got final is original times multiplier. So it's going to be 24,000 times 0.06. Okay, so just going to quickly tap that into the calculator. So 24,000 times 0.06, and that comes out to be 1,440. Okay, so that means they must have sold 1,440 more cups of tea than they sold cups of coffee. Okay, because that's 6% of the entire sales. And then for part B, it says, were more coffees sold in the cafe in 2019 compared to 2007? Now, you might think that was the case because, look, you've got 50 in that one, where the other one's 42. But like I said earlier, these are percentages, and you don't know how many drinks altogether were sold in 2019. Now, if they only sold 10,000 drinks in 2019, then 50% of 10,000 is going to be, 5,000, which is a lot less than 42% of 24,000. So it's not clear from the bar chart if the number of coffees sold is great in 2019, because you don't know 50% of what. Could be anything. So I'm going to say cannot tell, and I'm going to say the reason is we do not know the total number of drinks sold. Okay, because we don't know the total number, we've only got a percentage. Okay, we don't know. Okay, question 14, we've got a line graph. 40 students were asked the number of visits they made to a gym in 1 week, and the chart shows information about the results. Write down the modal number of visits. Now, mode is most, and on a bar chart that's really easy to find because it's just the tallest bar. And my tallest bar on the bar chart is this one, isn't it? It's this one here. Okay, so the number of visits was 1. That's the modal number because that occurred 10 times, which is more than all the others. Okay, and it says work out the mean number of visits. Okay, so give your answer as a decimal. Now, to work out a mean, you need to know the total number of visits and divide it by the total number of students. Okay, so we're told the total number of students. Here, look, there are 40 students. We could have got that by adding up all the frequencies as well. So like the 7 plus the 10 plus the 8 plus the 7. If we added all those up, we would have got the total number of students also, but it gave us it, so we don't really need to. So total students, that's equal to 40, and total visits, how many visits were there? Okay, well, 7 students made 0. 7 students made 0 visits, but then we also had 10 students that made 1 visit. We had 8 students that made 2 visits. We had 7 students that made 3 visits. We had 5 students that made 4 visits, and we had 3 students that made 5 visits. Okay, so we need to add all those up then. So that's 0, 10, 16, 21, 20 and 15. Now, adding all those up, just going to do that on my calculator quickly. So 10 plus 16 plus 21 plus 20 plus 15. Now that comes to 82. Okay, so that means there were 82 visits altogether by the students, and there were 40 students. So then the mean number of visits is going to be the 82 visits divided by the 40 students. So dividing that by 40, you can see that comes out to be 2.05 as a decimal. Okay. Yeah, so as a decimal, that's 2.05 then. And then part C says one of the 40 students is chosen at random. Work out the probability that the student visits at least once. Okay, probability that he visits at least once. Okay, now I could add up all the other bars and then divide that by 40, but I'm just going to use the fact that if they visited at least once, that's 1 minus the probability that they made no visits. Okay, because yeah, that's kind of like the opposite, isn't it? So at least one visit is 1, 2, 3, 4, 5. So if I just take the probability of getting 0 visits away from 1, I'll get the probability that they did any of the other number of visits. So that's going to be 1 minus. Now the number of students who made no visits, you'll remember, was 7 from the height of the first bar. So that was the probability that they made no visits is going to be 7 out of the 40 students who were all together. So 1 minus 7 40ths, or 1 is 40 40ths. So 40 40ths minus 7 40ths, that's 33 40ths then is my final answer. So probability of at least one visit was 33 over 40. Next topic we're going to be looking at is using a calculator. You need to be able to use your calculator effectively in the calculator paper. So let's have a look at some typing in some complicated things into the calculator, make sure we get it right. Okay, so the first thing we need to type in is 2.8 to the power 4 plus the root of 158.76. So I'm going to type in 2.8, then I'm going to press the power key, which is this one up here. Look, I'll get a little box up there and I'm going to type the number 4 into it. I then need to press the arrow key to come out of the box. You'll notice that when I do, the cursor goes from small to big. And then I'm going to add on the next part. So plus, and then I'm going to press the root key, and then everything else needs to go under that square root. So 158.76. Now, if you typed it incorrectly, it should just look like it does on the page. Mine does, so I'm happy with that. I'm going to press equals, and then write that as a decimal. That's 74.0656. So 74.0656. Okay. Now question 16 has a very similar structure. So I'm going to press 3, going to use the power key, going to put the 6 in it, going to press the right key to come out the box, going to press minus, then the root symbol, and then the 841. And yeah, looks like it does on the page, so I'm going to press equals, and that comes out to be 700. And then question 17, calculate the fourth root of 20,736. Now you can find the fourth root by using the shift key. It's the one above the power button. Now I normally put the power in first, so I type the power 4 and then I press shift and then that key. You'll see that it puts the 4 in the right place to start with. Now you can do it the other way. You can press the shift and that thing first and then type the 4 in, but I don't know. I just go for shift and press it like that and it goes straight in. And then my cursor's already in the right place for the number part then, which is 2736. That comes out to be 12 apparently. Question 18, I've got C is equal to 250 minus 16 squared and D is equal to 18 times 14 over minus 28. Work out the value of C times D. So I think the easiest thing is probably to work out C, work out D, and then multiply the two things together. You could use brackets and just do it all at once. That's the alternative way of doing it. So yeah, either would work. I think I'm just going to work them out, write them down, because I think with these you might get method marks for doing some of it. So 250 minus 16, and just using the square key, that comes out to be -6, and then 18 times 14 divided by minus 28, that comes out to be -9. Okay, so then I've got -6 times -9. Now I'm just going to do the negative times negative in my head and say, well, negative times negative is positive. And I'm just going to, I know 6 times 9 is 54. So I know my answer is going to be positive 54 for that one. Okay. Question 19. Use your calculator to work out 9.95 squared times 29.8. Give your answer as decimal. Write down your full calculator display. Okay, so I'm going to write 9.95. Use the square key. And then I'm going to multiply that by 29.8. Write down the full calculator display. So that's 2950.27452745. And then it says part B, is your answer to part A sensible? Use approximations to decide. You must show your work in. So this next part is just saying, can you use approximations to check if you haven't made a mistake in your first part of the calculation? I can do that by rounding each of these numbers off to one decimal place. So I've got 9.95 and 29.8. Now I can do that by rounding each one of my numbers off to one significant figure and then doing the calculation in my head using that then. So let's take 9.95 to start with. Rounding that off to one significant figure, the first significant figure is that 9 there. Look, so if I round it off after the 9, I'm going to get 10. So that's going to be 10 squared, and I'm going to multiply that by. Now again, if I want to round this one off to one significant figure, I'm going to round it off after the 2. Next digit is a 9, so I'm going to round that one up again. So that's going to round up to 30, isn't it? So it's going to be 10 squared times 30. Now 10 squared is 100. Times 30 is going to be 30 plus 2 extra zeros. It's 3,000. Now I made my answer 2,950, which is about 50 away. It's not too far off, is it? So I'm going to say yes, my answer is sensible because it's of the right magnitude. It's not a million miles away. Yes, it's sensible. Okay, add a tick box. Let's tick it there. Sensible. Similar question for question 20. First we need to do it properly with the calculator. So I'm going to use the fraction key so I can write it down like it is on the page. I've got 9.73. Use the power key, put the 3 in, and I press the down key to get down to that bottom box. I'm going to write 1.875 in there, and I'm going to press the right key to come out of the fraction. Then I can press the plus and then the 6.4 squared. Now if you have a look at my screen, it looks just like it does on the page over there. So I should be good. Okay, so I'm happy with my calculation. So pressing equals, I get 535.285. So 535.285. Okay, so doing the same thing, going to round each one of these to the nearest whole number. So 9.75 is going to be 10, 1.875 is going to be 2, and 6.4 is going to be 6. And then doing the same calculation again then, it's going to be 10 cubed over 2 plus, why did I write 4 there? It's 6. Plus 6 squared. Okay, so what's that then? 10 cubed is 1,000, 10 times 10 times 10. And then 6 squared is 36. Half of 1,000 is 500 plus 36. That's going to be 536 is our answer then. Now remember we got 535, which is pretty close, isn't it, to my answer. So is my answer sensible? I've got a little tick box here again, so I'm going to tick yes. Yes, it is sensible. Next up, we got area. This is really not a hard topic as long as you can remember all your various formula. Okay, for some reason, students always get these muddled up. I don't really understand why. Learn your formula. Just make up some revision cards until they're stuck in your brain. So you need the formula for a square, triangle, parallelogram, trapezium, circles. Yeah, that's about it, really. Remember all those, you're good. So question 21, a large rectangle that has a rectangular hole cut in it. Work out the percentage of the large rectangle that is shaded. Okay, so we've got two areas. We've got the area of the big rectangle, and we need to find the area of the small rectangle, take it away, and then we can work that out as a percentage. Okay, so I'm going to call this one area 1, the big rectangle, and this one area 2. Okay, so area 1 then is going to be 5 times 4, length times width, which is going to have an area of 20. And area 2 is going to be 2 times 3, which is 6. Okay, so then the shaded area is going to be the big one minus the small one, isn't it? So it's the 20 minus the whole, which was 6. It's going to have an area of 14. And then the percentage is going to be the shaded area, which is 14, over the total area, which we knew was 20, but rewritten as a percentage. So if you just do 14 divided by 20 times by 100, it should tell you that that is 70%. Okay, so that's 70% is shaded. Okay. Question 22, here's a shape made from rectangles. Work out the area. So this is a compound shape made out of 2 rectangles pushed together. So what we need to do is we need to cut it up into 2 smaller rectangles and then work those out separately, add them together. Now you can either cut it this way or you can cut it this way. It doesn't really matter as long as you've cut it up and you work out your 2 separate areas and then recombine them. Okay, so this left-hand rectangle, area 1, that's going to be 8 times 4, isn't it? Which is going to have an area of 8, 16, 32. Okay. Now this other one, don't use 9 and 2. Well, 2 is the width, but it's not 9, is it? Because we've kind of taken a bit off of here. This 4 here, look, is here. So that means that this part must be 9 take away 4. It's going to have a width of 5, isn't it? So it's going to be 5 times 2, which is going to have an area of 10. So then the total area is going to be area 1 plus area 2. It's going to be 32 plus 10, which is 42 centimeters squared. Question 23, the L shape is made from rectangles. Going to do the same thing here. Going to divide it up into different rectangles that I can then work out the volume, that I can then work out the areas of separately, and then I can then add those together to find the area. Oh no. Question 3, the L shape is made from rectangles. Yes, it is. The area is 44. Work out the perimeter. Okay, so this time we've been given the area. We need to kind of work backwards to work out any missing lengths and therefore what the perimeter would be. Okay, so if the area is 44, what shapes have we got here? Again, let's divide this up. I've got this one is 7 times 2, which has an area of 14. So if it was 44 altogether, then the other rectangle must have 44 minus 14. It must have an area of 30. Okay, now I can see that this length here is 3. So then that one there, when I multiply it by 3, I get 30. So that must be equal to 10, mustn't it? I might actually write it here because then it's not confusing with the other side. So that one there must be 10. So then the long side along the bottom must be the 10 plus that extra 2 up there, mustn't it? So 10 plus 2, that's 12. Okay, so now I've got all the missing sides. I can add them up then. So the perimeter is going to be starting in the top left corner and walking around the shape. I'm going to get 2 plus 4 plus 10 plus 3 plus 12 plus 7. Adding all that up, that is going to be 38, I believe. Question 24. ABCD is a trapezium. Calculate the area of ABCD. State your units of your answer. Okay, so the formula for the area of a trapezium is a half A plus B times H, where A and B are 2 parallel sides and H is the distance between them. So where are the 2 parallel sides? I've got one here, look, which is 10, and one here, look, which is 20. So they're my 2 parallel sides. They're the values that go in here, look. Essentially, you're adding the 2 parallel sides together and dividing by 2. You're finding the average of those 2. So 10 plus 20 is 30, divided by 2 is 15. So it's going to be a half of 10 plus 20 times the distance between them. The distance between them, this one, is just that that distance there, isn't it? That's going to be the h, the height of the trapezium. So it's going to be half of 10 plus 20 over to multiplied by 8. Right, so as I was saying, if I find the average of 10 and 20, 10 plus 20 is 30, divided by 2 is 15. That's the same thing as 15 times 8, and 15 times 8 is 80, and 40, isn't it? It's 120. So that's going to be 120. Question 25, which shape has the greatest area and by how much? You must show your work in. So essentially we need to work them both out and then show how much bigger one is compared to the other. Right, so we know how to do both of these. One is a trapezium, which we've just looked at finding the area of, and one is a composite shape made out of rectangles, so we know how to do that as well. So we're going to divide up our shape. Now I guess I could divide it up into 3 rectangles and work them out, adding them all up. Alternatively, you could think of this as one rectangle with a big rectangular hole. So like if I can work out the area of that rectangle and take it away from the bigger rectangle, a bit like we had earlier, then I can say it's the green rectangle with the kind of yellow rectangular hole taken out of it. Okay, so the big rectangle is going to be 11 times 9, which is 99. And then if I then take away the smaller rectangle, which is 7 by that distance there, what's that distance? Well, this distance is 11, look. And this distance is 2, and this is 2. So if I take those two 2's away from 11, it should give me the yellow bit in the middle, shouldn't it? So that's going to be 11, take away 2, which is 7. So that hole in the middle is actually a square. It's 7 times 7, which I know is 49. Okay, so then the area of the rectangle is going to be 99 minus 49, which is equal to 50. Okay, so we're half done. So that's the area of the rectangle, or the L shape, isn't it? And then moving on to the trapezium, area is going to be, again, it's going to be half a plus b times h, where a and b are 2 parallel sides. So that's going to be a, that's going to be b. So that's going to go there and there, a and b. So we're going to add our 2 parallel sides together and then halve them. So half of 6 plus 9, and then we're going to multiply that by the distance between them. So the distance between them is that 7 there then. Okay, so half times 6 plus 9 times 7. Well, 6 plus 9 is 15, half of 15 is 7.5. So it's 7.5 times 7. So I'm just going to do it on a calculator, I think. 7.5 times 7, and that comes out to be 37.5. So which is bigger? The shape on the left is bigger. So first shape is bigger by, and then how much is it bigger though? So I need to do 50 minus 37.5, so the difference is 12.5 then, so it's by 12.5 square centimeters. So the first shape is bigger by 12.5 centimeters. Next up, we've got indices. So you need to remember your various laws of indices. When you multiply numbers with the same base, you add the indices. When you divide numbers with the same base, you subtract the indices. And when you raise an index to a power, you multiply the indices. So we've got that first one here, where we've got x raised to the power of 3, and then that is then raised to the power of 2. So we work that out by multiplying the 2 indices together. That's going to be x to the 3 times 2, which is going to be x to the 6. Okay. Next one, we've got 2 numbers with the same base, and we're dividing. So here we need to subtract the indices. 8 subtract 2, that's 6. So that's going to be y to the power of 6. Here we've got 2 numbers with the same base, and we're multiplying them together. So with this ones, we add the indices together. So that's going to be a to the power of 20 plus 5. It's going to be a to the power of 25. Then we've got 2 numbers with the same base that we're dividing. So we're going to subtract those indices from each other. So that is going to be a to the 20 minus 5. It's going to be a to the 15. Question 28, work out 5 to the power 12 divided by 5 to the power 3 times 5 to the power 2. I'm going to do this in two parts. Just work out this bit first. 5 to the 12 divided by 5 to the 3. Got two numbers of the same base, I'm going to subtract the indices. 12 subtract 3 is 9, so that's going to give me 5 to the 9, but I then need to still multiply it by 5 squared. Again, I've got two numbers with the same base, so I'm just going to add these two indices together. 9 plus 2 is 11. So my final answer is 5 to the power of 11. Okay. And then question 29, write as a single power of 9. I've got 9 to the 5 times 9 to the power of 7. So notice we've got the same basis everywhere. But we're going to be adding these indices together. So 5 plus 7 is going to be 16. So that's going to be 9 to the power of 16 divided by 9 to the 4. And then again, we've got two numbers with the same base. We're dividing them, so we're going to be subtracting these indices from each other. So 16 subtract 4 is 12, so it's 9 to the power of 12. Question 30, everything with the same base here again. Going to be adding when we're multiplying, and we're going to be subtracting when we're dividing. Okay, I'm going to do it in two steps just to break it down a little bit, capture. It's out of 2 marks, isn't it? So you get 1 mark for doing the top part. Better to break it down and kind of bank your marks as you go along. So 4 plus 5 is 9, so we're going to get a to the 9 divided by a to the power 3, and then subtracting the indices. 9 take away 3 is 6, so the final answer is a to the 6. Okay. Question 31, Lucy wants to simplify 3p squared times 5p to the 7. She says add 3 and 5, then add 2 and 7. Her answer is 8p to the power 6. Is she correct? No, she's not. Okay, well, partly she's correct. I mean, yeah, we did say we can rewrite this, you know, because multiplication is commutative. It doesn't matter which way around we do it. I can say that's the same thing as 3 times 5 times p squared times p to the 7, just rearranging it. So just like we had earlier, for this part we've got two numbers with the same base. We're going to be adding those indices together. So we are going to be adding 2 and 7 together. Now that part is correct. Okay, we should get p to the power of 9 for that. Okay, but we're not adding the 3 and the 5 together. We're just going to multiply these together. They don't have the same base, so we're just going to multiply them together. 3 times 5, that is 15. So we're not adding them together to get a, we're multiplying them together to get 15. So that is not correct. Question 32, next up we're multiplying out brackets and factorising them back in again. So multiplying out 3 lots of 2x plus 5. Now when you've got a number outside the bracket like this and you want to remove the brackets, you need to multiply everything inside the bracket by that thing on the outside. So we're going to do 3 times 2x to start with, that's 6x, and I'm going to do 3 times 5, which is 15. So that's my final answer then, 6x plus 15. Factorising is going back the other way, and that's putting brackets back in again. So what goes on the outside of the bracket is what's common. So what's common for 8x and 4? Well, 4 is a factor of 8x and 4 is a factor of 4. So I can take 4 out. And then inside the brackets is what I'd need to multiply by 4 to get my original numbers back again. So 4 times what is 8x, that's 2x. And 4 times what is minus 4, it's minus 1. So that's my factorised form of that. 4 lots of 2x minus 1. Question 33, factorise 12a plus 15b. So again, what's common in here is the number that divides into 12 and into 15, which is 3. So I can take 3 out as a common factor. 3 times what is 12a? It's 4a. 3 times what is 15b? It's 5b. So I'm going to get 3 lots of 4a plus 5b as my factorised version of that expression. Question 34, factorise 21x plus 28. What number goes into 21x and also goes into 28? Well, both of those numbers are in the 7 times table, aren't they? So if I take 7 out, then 7 times what is 21x? It's going to be 3x. And 7 times what is 28? It's going to be 4. So that's my final answer, 7 lots of 3x plus 4. Question 35, factorise 15x plus 5y. Well, 15 and 5 are both in the 5 times table, so let's take 5 out. That's going to leave me with 3x plus y inside the bracket like that. So 5 lots of 3x plus y. Right, these are getting a little bit more fun. We've got 2 pairs of brackets that we need to multiply out. multiplying out the first bracket to start with, 3 lots of 2x is 6x, 3 lots of minus 5 is minus 15. And then in the second bracket, we're going to be multiplying everything in the bracket by 4. 4 lots of 2x is 8x, and 4 lots of 1 is 4. Okay, now at this point, you'll notice we've got terms in x, which we can combine, and we've got numbers that we can combine. Okay, so adding the two terms in x together, 6x plus 8x, that's 14x. And minus 15 plus 4, if you're at negative 15 on the number line, you add on 4. It's going to take you up to negative 11. So that's my final answer then, 14x minus 11. Okay, so that was the x terms added together. That was the numbers added together. Now this next one is a little bit more tricky because you've got this minus sign in the middle here, so you need to take care with this one. So multiplying out the bracket first from the first one, same as before, 5 lots of 3x and 5 lots of 4. That's going to give me 15x plus 20. But this second one I'm going to be multiplying by minus 2, so just take care with that. Negative 2 times x, that's minus 2x. Negative 2x times negative 1, that is plus 2. Now the sign, getting the sign right on that last term is going to cause quite a few students some issues. So just think about negative times negative is positive and make sure you're being consistent with signs. Okay, now again, once we're done, looking to collect like terms, I've got 15x minus 2x. That's going to give me 13x. And then I've got 20 plus 2, haven't I? Okay, 20 plus 2, that's going to give me 22. Now I know lots of students would make a mistake on that one. They get the 2 sign wrong at the end, and therefore their final answer is not going to be 22. They're going to write down 18 and be very sad when they lose a mark. Okay. Right, next up I've got a similar question. 4 lots of 2c and 4 lots of 3 is going to give me 8c plus 12. Now this thing here, we've just got a minus sign there, no number. That actually means minus 1, isn't it? It's minus 1 lot of that bracket. Minus 1 lots of 5c is going to be minus 5c. And minus 1 times minus 1 is actually plus 1. So again, the sign flips on that last term because a minus times a minus is a plus. So collecting like terms, we've got 8c minus 5c. That's going to give me 3c. And 12 plus 1 is 13. So I'm going to get 3c and 12 and 1 make 13. That's my final answer. 3c plus 13. Right, then I've got factorise 18x minus 42y plus 30z. And I've got 3 terms here, but they're all multiples of 6, aren't they? So if I take 6 out as a common term, then 6 times what is 18x is going to be 3x. 6 times what is minus 42y, it's going to be minus 7y. And 6 times what is 30z is going to be 5z. Okay, so that's what I'm going to get. 6 lots of 3x minus 7y plus 5z. Next topic is quadratic expressions and equations. So we're going to have to learn how to multiply out double brackets, also factorising quadratics into 2 brackets, and how to solve in that way. Okay, so expanding first. Now I do highly recommend you do this as a grid. So I've got y and 5 and y minus 4. I see lots of students try and do these on the fly and they drop a term in an exam and often get them wrong. Drawing out the grid like this is just a reminder where all the 4 values that you need to put down go. So it gives you structure to remember how to do it properly. So y times y is y squared, y times 5 is 5y, y times minus 4 is minus 4y, and 5 times minus 4 is minus 20. Now you'll notice I've got a term in y squared there, so that's going to be part of my solution. Now I've actually got 2 terms in y. I've got 5y minus 4y. So if you're at 5 on the number line, you take away 4, you get to 1y or just y. And then at the end there, I've got a minus 20. So I'm going to have a minus 20. So it's y squared plus y minus 20. Okay. Right, similarly, question 41, multiply out, simplify x plus 5, x minus 1. So again, do a grid. It helps you, gives the structure, helps you not miss out terms. So I've got x and 5 and x and minus 1. Multiplying those together, x squared, 5x minus x minus 5. Okay, so again, we've got a term in x squared, we've got two terms in x, and we've got a minus 5 on the end. So writing that down then, I'm going to have an x squared term, 5x minus x is 4x, and then I've got a minus 5 on the end. Question 42, expand and simplify y plus 8y minus 3. Doing the grid, y 8, y minus 3, multiplying y squared 8y minus 3y minus 24, collecting y squared 8y minus 3y minus 24. So that's y squared 8y minus 3y, that's 5y minus 24. Okay? Multiply out and simplify x minus 8 all squared. Well, x minus 8 all squared is x minus 8 times x minus 8. So I've got a double bracket still, it doesn't look like it immediately. So I'm going to have x minus 8, x minus 8 like that. Okay, so x times x is x squared, x times minus 8 is minus 8x, going to have another minus 8x there, and minus 8 plus minus 8 is plus 64. So again, I've got an x squared term, x squared, I've got two terms in x, minus 8x and minus 8x, which you add together, you're going to get minus 16x. And then I've got a term on the end, which is 64. So plus 64 on the end. Right, question 44. We're not expanding anymore, we're factorising. Factorising is the opposite of expanding. It's putting the brackets back in again. So I kind of know that when I have two brackets and multiply it out, I get a quadratic. So if I factorise a quadratic, I'm going to end up putting my things back into a double pair of brackets. I start off by thinking about that number at the end, the 15. Factor pairs of 15 are 1 and 15, 3 and 5. Now, which one of those pairs is going to add up to 8? Because that's what I need to get in the middle. It's going to be that one there, isn't it? 3 and 5. Okay, so factorise 15 first, and then we think about which one of those pairs is going to give you the middle term, and that is the pair that we need. So I'm going to get x plus 3, x plus 5. Now, if in doubt, if you're a bit shaky on these, at this point, just double check by multiplying the brackets back out again and see if you got back what you started with. Okay? And if you're happy with it, you can move on. Question 45, write down two solutions of y plus 2y minus 4 is equals 0. Now, I've got two things multiplied together and they're equal to 0. When that happens, if you've got something times something equals 0, the only way that can happen is if one of the things to start with was 0. So either y plus 2 is equal to 0, or y minus 4 is equal to 0. Now, if y plus 2 is equal to 0, it must be that y is equal to minus 2, because minus 2 plus 2 is 0. And if y minus 4 is equal to 0, it must be that y was 4, because 4 take away 4 is 0. So my answer is minus 2 and 4. Next up, question A, expand and simplify x plus 5, x minus 4. That's multiplying out brackets, drawing the grid, x5, x minus 4. It's going to be x squared, 5x minus 4x minus 20, which is x squared plus x minus 20. Okay, and then next part is solve x minus 8, x plus 7. So either this bracket is 0 or this bracket is 0. If x minus 8 is equal to 0, then x was 8. If x plus 7 was equal to 0, then x is minus 7. You know, it's like the sign is flipped on the answer compared to how it looks in the brackets. Okay, so there are my two solutions. X equals 8, x equals minus 7. Question 47, x squared plus 7x plus 10. I need to factorise it. Looking at the number on the end, the 10, and thinking about factor pairs of 10. What are the factor pairs of 10? I've got 1 and 10, 2 and 5. Which one of those pairs adds up to the middle term of 7? It's that pair there, isn't it? So this is going to factorise into x plus 2, x plus 5. Okay, so x plus 2, x plus 5 is my solution. Next up, we've got Pythagoras Theorem. Now, for Pythagoras Theorem, you need to know the formula. C squared equals a squared plus b squared. You need to be aware of the fact that when you are finding the long side, you square and add and square root, and when you're finding one of the shorter sides, you square and subtract and square root. And it would also be very handy to know your Pythagorean triples like 3, 4, 5, 5, 12, 13. They come in handy for these sorts of questions. Right, but anyway, let's crack on. Basic Pythagoras question for question 48. I've got two sides of a right angle triangle and I want the long side, the hypotenuse. So when we're finding the long side, we square and add and square root to find the solution. So c squared equals a squared plus b squared. So we're going to square 32, we're going to square 60, we're going to add them together and we're going to square root. Now, as long as you've got that written down, you can just then work it all out in one go on your calculator. So I'm just going to press in the square root of 32 squared plus 60 squared. Okay, and then I'm going to get 68. Now this was a 3-mark question, but I would have got both the method marks from here. There's no need for me to write anything more down than that. So then 68 is the final answer. Is going to give me my full answer and my full credit for those. Okay, so make sure you're writing enough method down to get all the method marks, even if you get the final answer wrong. But yeah, just speed things up for yourself when you type it into the calculator. So anyway, that came out to be 68. Right, question 49 though. Why is not the long side of my triangle? It's the shorter side. So normally we've got c squared equals a squared plus b squared, but if we're getting one of the shorter sides, it's going to be more like a squared equals c squared minus b squared. It's going to be the big side squared minus the shorter side squared. Okay, so for this particular question, I'm going to get y squared is 14 squared minus 9 squared. Okay. Now, as long as I got that written down, I can now just go on and work out what y is. I'm going to type in root and then 14 squared minus 9 squared equals, you can see that comes out on my calculator as root 115, which is 10.7 to one decimal place, or 3 significant figures. Give your answer as a decimal. Okay. Well, it's not expecting us to write it all down. I think 3 significant figures is fine. 10.7 is fine for that one. Question 50, work out x as a decimal. Again, x is one of the shorter sides here. So x squared is going to be 8 squared minus 3 squared. I'm going to square, subtract and square root for this one. So then x is going to be the root of 8 squared minus 3 squared, which my calculator says is root 55, or as a decimal that is 7.42. Now I normally round off to 3 significant figures unless it tells me to do otherwise. I think that's a good level of accuracy to give your answer. So 7.42 is my final answer. Question 51, the diagram shows rectangle ABDE and right angle triangle ABC. AC is 17, B is 8, BC to CD is in the ratio of 1 to 2. Work out the area of rectangle ABDE. Right, so we've been given this ratio here of BC to CD, which is in the ratio of 1 to 2. Now, where is BC? BC is that distance, and CD is that distance. Now, if these are in the ratio of 1 to 2, but the yellow bit there is length 8, then that's 8 times bigger than 1, isn't it? Okay, so if I multiply this side up by 8 as well, I'm going to get 16. So that tells me this green bit is 16. Okay, so if the green bit is 16 and the yellow bit is 8, then the distance all the way across, like that distance there, is going to be 8 plus 16. That's going to be 24, isn't it? Okay. Now, if we want to work out the area of the rectangle, we know now the length, but we also need to know like the height of it or the width of the rectangle. Now, the width or the height of this rectangle, this length here, look, that happens to be one of the sides of my triangle, where I know the other two sides, so I can use Pythagoras Theorem there to find AB. Let's call it x for now. X squared, x is going to be one of the shorter sides, isn't it? So I'm going to be squared and subtracting the square root in here. So x squared is going to be equal to 17 squared minus 8 squared. So tapping that into my calculator, I'm going to write root 17 squared minus 8 squared. And that comes out to be 15. So x is 15. So then that side there is 15. And therefore the area of the rectangle is going to be the length of the rectangle, which is 15, times the width of the rectangle, which is 24. So 15 times 24, that's going to be 240, and half of 240, it's going to be 360, isn't it? So that's going to be 360. Right, next topic we've got scatter graphs, and question 52 says players score some points in a game. The scatter graph shows the time and the points scored by some players. Circle the strength and type of the correlation shown. Now here we've got clear correlation running upwards from left to right, haven't we? That is positive correlation because the line is sloping upwards. Okay, now all the points are really quite close to the line. There's not any outliers. They're not exactly sitting together like soldiers, but they're pretty close to that line. I'm saying that's strong correlation. So it's strong and it's positive, so I'm going to go for strong positive. Now part B says players get 1 extra life every 2,000 points they score. Jonah plays the game for 15 hours. Use a line of best fit to estimate the number of extra lives he gets. Okay, so I just kind of quickly drew a line of best fit on there already. Just going to kind of do that again just to show you how to do it because I wasn't really thinking of it. So you want to try and get your line sort of angled through your points as best you can. Some people say it's a good idea to get like the same number of points on either side. It's just a rule of thumb really, it's not an absolute. But yeah, you just need to try and get a nice line of best fit going through your points like that. Now you do get a little bit of wiggle room, so some people might draw it slightly higher, some people might draw it slightly lower. It's not really a problem, as long as you're using your values to look your numbers up from, that is fine. Okay, so players get 1 extra life every 2,000 points. So number of points in thousands along the top. So every 2,000 points they score a point, and Jonah plays for 15 hours. So if he plays for 15 hours, how many points has he got first off? So if I read up from 15 up to the to my line of best fit, when I get to the line of best fit, go off in the other direction. So that ends up there. Now I've got 5 little squares between 30 and 40, so each one of those little squares must be 2. So I would be reading that off as 34. But it's 34,000, so it's 34,000. So it means he scored 34,000 points. So score is 34,000 from the graph. Now if you're scoring an extra life every 2,000 points, if I divide that by 2,000, then 34 divided by 2, that means he's getting 17 extra lives, and doesn't it? Use a line of best bit to estimate the number of extra lives he gets. I reckon he's getting 17 extra lives. Question 53. A cafe owner records the average monthly temperature and the monthly sales of soup over a year. So you've got months of sales of soup up, monthly sales of soup up the y-axis and average monthly temperature along the bottom axis. The scatter graph shows negative correlation. Write down the relationship between average monthly temperature and the monthly sales of soup. Okay, so if you're talking about relationships rather than correlation, you need to say either the more of this one, the more of that one, or the more of this one, the less of that one, depending if you've got positive or negative correlation. So positive correlation, you would say the more of this, the more of that. If it's negative correlation, you say the more of this, the less of that. So in this case, the higher the average monthly temperature, the less sales of soup there are then, isn't it? So as one increases, the other decreases. So the higher the average monthly temperature, then the less sales of soup. Okay, so as one goes up, the other goes down. So as long as you've written something like that in there, you're going to get the mark. Right, so the average monthly temperature for the next month is predicted to be 7 degrees. Use the graph to estimate the sales of soup that month. You must show your working. Right, now in order to do an estimate from a scatter graph, you need to draw on a line of best fit. Okay, so we're going to draw a line of best fit first through our data set. So just trying to get the same number of points on either side. If you've got like a clear ruler like this, sometimes it's a good idea to try and group them under the clear ruler. So, and then once you kind of got them grouped under the ruler, you can just kind of drop your ruler down a little bit and then draw your line of best fit. So this is a bit of a top clear ruler hack. Okay, like that. So there's my line of best fit going down. Now again, it's not an exact science. If yours looks slightly different from mine, don't worry, just use yours, look up your value, write down your answer. Okay, so average monthly temperature in next month is predicted to be 7 degrees. So find 7. So I've got 10 divisions between 5 units here. So each one is like, I need 2 squares for 1. So 7 is going to be 4 squares up from 7, and it's going to be there. Okay, so reading up from 7 till I get to my graph. And then I'm going to go turn the other way. What's that then? So I've got 1, 2, 3, 4 little squares up from 400. Now there are 10 squares between 400 and 600. So that spans 200 units in 10 squares. So 1 square would be 20. So 4 squares would be 4 lots of 20. So I'm reading that as 480 then. That's going to be 480 on my scale. So that means that monthly sales of soup I'm estimating to be 480 tins. I don't know. So use your graph to estimate the sales of soup that month. 480. Now it says you must show your working. My working is the line on the graph. Okay. So I don't need to do anything other than write down 480 because I've already done my method. I wrote it on the graph. Right, next section is pie charts. Now with pie charts, the most important thing to remember is most of the marks come from the table and not from the pie chart itself. You need to get the table right. Get the table right, everything will be right, you'll get all the marks. Don't get the table right, you're stuffed, you're not going to get anything. Okay, so the table shows where 72 people went on holiday. Okay, now we need to draw and fully label our pie chart. So at the moment we know that the number of people that we need to represent adds up to 72. Now how many times does 72 go into 360? Because we need to represent these 72 people on a circle which are made out of 360 degrees. So to work out the relationship, how we're going to switch between them, we need to do how many times 72 fits into 360. So 360 divided by 72, I believe that's 5, isn't it? But I'll just double check. 360 divided by 72, that's 5. Okay, so it goes in 5 times. So that means if we take each of the number of people and multiply it by 5, I'm going to get the angle that I need to represent those people on the chart. Okay, so Spain was 36 people. I times that by 5, I'm going to get 180, aren't I? So 18 times 5, 6 times 5, 12 times 5, what are they then? So 18 times 5 is 90, 6 times 5 is 30, 12 times 5 is 60. Now if you've done this all right, it should add up to 360. Might be worth double checking. Okay? Right, now, first up, 180 degrees, that's pretty easy. That's just a straight line, isn't it? So if I just draw a straight line across from there to there, then that must be, in that top half of my graph, must be all the people who went to Spain. So I'm just going to label that one up Spain. Okay, Portugal is a 90-degree angle. Now again, 90 is quite easy to do. I just need to go draw a line straight down, a right angle. Okay, so I'm going to draw a line going down like that. So that's going to be Portugal. And then Turkey is 30 degrees. I'm going to have to use my protractor for that one. So laying out my protractor along the last line I drew, count round to 30 and make a mark. I'm going to make my mark here, and then I'm going to join up my line through the mark that I made like that. Okay, so the small one was Turkey. and the larger one was other. Okay, and there's my completed bar chart. And there's my completed pie chart. Okay, so you don't need to write the angles on. You do need to label the sections though, and the angles need to be correct to get the marks. Now, question 55 says not drawn accurately, which is handy, which means I don't have to do any measuring with my protractor. Everything can be done mathematically, which suits me. So, question 55, some people were asked for the main way they listen to music, and the pie chart is drawn to represent their answers. So CDs, computer, radio, phone, and other. Work out the size of angle X. Right, well, all these angles at the center have to add up to 360, don't they? Just take care, that one there is 90, it's not nothing. Okay, so make sure you include that 90 in your calculation. So my two x's, x plus 162 plus the 40 plus the 90, added all together, that should be equal to a full turn, so that's 360 degrees. So x plus x is 2x, 162, 40, and 90, that adds up to, what's that, 130, 292. So 2x plus 292 is equal to 360. So taking 292 away from both sides, that's going to leave me with 68 on this side. So 2x is 68. So then dividing both sides by 2, I'm going to get 34 degrees then for x. X is 34. And then it says 135 people said computer. So if this was 135 people, how many people said phone? Well, computer is 1/4 of the data set, isn't it? So the total people asked must be 135 times 4 then, isn't it? Because if computer is a 90-degree angle, which is a quarter turn, then if I take the number of people who use a computer and times it by 4, I'll get the total number of people then. So doubling 135, I'm going to get 270. Double it again, I'm going to get 540. So that means they must have had 540 people to ask. Then the phone is 162 degrees. So to find out how many people that represents, so phone, that's going to be the total number of people times by, and I'm going to write that down as a fraction, 162, which is the angle at the center, over 360, because that's the fraction of the whole circle you've got. So if I take 540, the total, and I times it by 162 3/60ths, I should get then the number of people who use their phone. So 540 times by 162 over 360 comes out to be 243 people. Okay, that's my final answer then. 243. Okay, question 56 again, not drawn accurately, so don't have to get my protractor out. Woohoo, prefer that. So the angle for mammals is 175 degrees more than the angle of reptiles. So whenever we're given one thing relative to the other, we don't know what that thing is, there's a good chance to use algebra. So if we say that the reptile angle is x, then the mammal angle is going to be the reptile angle, which was x, plus the extra 175. So that angle there is x plus 175. Okay. Now we're given the total number of animals altogether, what all of these add up to, and we need to work out the number of mammals in the zoo. Right, so I know that those three angles need to add up to 180, don't they? Those three angles together. Now, I know that those three angles together need to add up to a full turn, or 360. So the x for reptiles, plus the x plus 175 for mammals, plus the 125 for insects, must be equal to 360 degrees. Okay, so then adding like things together, x plus x is 2x, 175 plus 125, that adds up to 300, and that's equal to 360. So taking 300 away from both sides, I get 2x is equal to 60. So then dividing both sides by 2, I get x is 30. So if x is 30, then the mammals would be x 30 plus 175. That's 205 degrees. and the reptiles will be just 30 degrees. Okay. Now, I know that there are a total of 4,680 animals in the zoo. Now I want to know the number of mammals. So this is a bit like what I did just a second ago. If I take the total number that they gave me, 4680, and I times that by the fraction that is mammals, which is 205 out of 360, then that should tell me the number of mammals then, isn't it? Okay, so into my calculator goes 4680 times by, and then 205 over 360 as a fraction. That gives me 2,665 mammals. Okay. Oh no, they haven't said here that it's not to scale, so I might have to actually use my protractor. It's annoying. So anyway, but question 57, some players were asked the shirt colour of their football team. Each answer was either white, blue, red or green. The pie chart is drawn to represent the answers. 2 of the sectors are drawn. The number of answers red Okay, so we've got like the blue and the white one drawn. So we've in this kind of remaining sector here, we're going to have to divide this up into 2 sectors at some point. So part of it will be red and part of it will be green. But I guess it's going to tell us how to do that in the rest of the question. Okay, so the number who answered red is 3 times the number who answered green. Complete the pie chart. Okay, so what angle have we got here to share out between these two to start with then? What's the remaining angle there? Okay, so we've got 165 and 75. If I take that away from 360, it should tell me what's left to share out between my red and my green sector. Okay, so 360 minus the 165 angle plus the 75 angle. So 165 and 100 plus 75, that comes to 240, I believe. So 360 minus 240, that's going to give me 120. So I've got 120 degrees here, look, that I need to share out between these 2 sectors. And I know that the number who answered red is 3 times the number who answered green. So as a ratio, red to green is in the ratio of 3 to 1. Okay? So essentially what I've got here is a dividing by a ratio question. I need to divide out the angle of 120 degrees between the red and the green in a ratio of 3 to 1. So if I've got 3 shares and 1 share, then altogether I've got 3 plus 1 equals 4 shares. If I divide 120 by 4, if I do 120 divided by 4, I get 30. So if I take my ratio 3 to 1 and I scale it up by a factor of 30, I'm going to get a 90 degree angle and a 30 degree angle for red and green, then, aren't I? Okay, so I need to then take my remaining 120 degrees and divide it up into 90 and 30 degrees. Okay, so we either draw the 90 and the 30 draws itself, or we draw the 30 and the 90 draws itself. Might be easier just to draw the 90 degree angle. So putting my protractor on the diagram, and I'm just going to mark off 90 using my protractor. That. And then once I've made the mark, I can then just join it up. Okay. And then so the big bit is going to be red then, isn't it? And then the small bit is going to be green. And then the next part of the question says there were 600 players altogether. How many players answered white? Now, if you remember, there was a 75 degree angle for white. So we're going to take the total number, 600, and we're going to multiply it by 75, the angle at the center of the white sector, divided by 360, which is the total angle in a full turn. So it's going to be 600 times by 75 over 360. And that comes out to be 125 players. Okay, so that's my answer, 125. Question 58, the pie chart shows information about people at a fair during 3 days. Again, it's not drawn accurately, so I'm not using my protractor here. There were 132 more people on Friday than Thursday. Work out the number of people on Saturday. Okay. Well, if you look at the difference in the angles, so angle difference between Friday and Thursday is going to be 80 minus 25. So what's the difference between those two then? So 80 minus 25 is an angle of 55 degrees. And that must represent these 132 more people that were on Friday than Thursday. So if 55 degrees is equal to 132 people, what we need to work out is the number of people on Saturday, don't we? So what was the angle for the people on Saturday? Well, if I counted for 25 and 80 already, that counts for 105 degrees. So 360 minus 105, that means that this angle must be 255. Okay, so we know what 55 degrees is. It's 132 people. We want to represent 255. So what we could do is we could make that into a ratio. 55 degrees is 132 people, and then change it into 255 degrees, and then work out the number of people that is. Now I can do that using what's called the unitary method. So if I know that 55 degrees is 132 people, if I then divide it by 55 and then times it by 255, it should take me to the answer then. So to get the answer then, I'm going to do 132 divided by 55. I'm going to do the same thing on this side. Divide by 55 and times by 255. So what's that? 132 divided by 55, which is 2.4. And then 2.4 times by 255. That comes out to be 612. So I think there must have been 612 people then on Saturday. Well, I hope this video helped you get a better overview of the topic. If it did, give it a thumbs up. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.